cautionary tail wiggle here. If you're going to keep your seeds in the refrigerator, don't put them in the bottom drawer. Morning, y'all. Wiggle here. So there's the solar panel that I had put up for the DC fridge. Everything's working just fine. When I originally had set it up, I had drained 2 different 12-volt battery banks to nothing, trying to just get the thing working. And my solar charger was not working. The solar controller was not working. So I put a battery charger on there and charged the batteries back up while I'm running the refrigerator. And the battery charger got the batteries topped off, and it's been on solar power for a couple days now. And I just went up there and checked it, and it's at 13.3 volts on the battery bank. I may take one battery bank off and see how it does, but for now I'm just gonna leave it. I don't need the other battery bank. It's a 12-volt battery bank. So that's going well. Finally got the off-grid refrigerator working. Yesterday I welded up this rail from a meat locker. I had a little problem. Yeah, ugly weld, but I'm just working with a really cheap welder. So it ended up, I had some problems with clearance on this trolley where I had melted through a little bit, so I couldn't get a grinder to fit in there really that well. I ended up getting a circular saw with a metal blade on it, and I just set the depth just right, and I just put it in there and ran it back and forth. Then I tilted it a little bit to even out where the rails meet, because it turns out these are actually two different kinds of unistrut, so they don't meet up perfectly. But the most important part is just where that trolley is going across, so we shouldn't have a problem now. So we'll get that back up. I'll show you what else we're working on. Here's my tilted panels. They're doing fine. Let me go take you in the greenhouse real fast. So that little 180 volt array is overproducing water. We got our tank full, 3,000 gallon tank, and the solar well is still running, and we keep running it, and this water fills up, and yeah, it's blown out over there and washing down. It's supposed to go back over that way to the other ditch. So we're going to have to do some landscaping. Everything's just frozen and cold, so we're not doing landscaping right now. But anyway, it just runs down in front and makes a muddy mess. So I set the panel off for the pump off for a day or two at a time now. And I'll also update you on the other thing. We've had some, 10 to 20 degree nights, a number of them in a row. So I wrapped, let me just walk over there. So it is a cold day. It's barely going to break freezing today. It's cold for us here. I know that's not cold in some places. Cold enough for us here though. So I ended up wrapping another layer of R10. So the sides are now R20 and the top is R20. And I ran this little heat tape down in there. It's 110 volt, unfortunately. So I had to run this cord all the way over here. And we did have that freezing that one time. So that, and it's a really small, it's like 6 foot, and it's like barely any power at all. Very low draw on that heat tape. But when I take the lid off, when I open this up, and if I take that lid off down there, you could feel the heat just come up out of it. So the heat tape has done the job. I'm going to tell you about that as I walk over here to the greenhouse. Show you my other solar project. I had ordered some halogen, 50 watt halogen bulbs, 24 volt DC, and I was going to run those in there because I don't want to have that stupid cord running over there. I want to be off grid, not on grid. So for instance, if we lose the power, I'm still using AC, regular meter box and all that. If we lose that, then I have a chance of freezing up my well or my pressure pump. That's why I wanted to switch over to the 24 volt DC bulbs that I could just wire into the same wire and hopefully use that to keep it heated. But I ordered those, of course. Ground's really frozen. I ordered those, of course, and before they're even here, I've come up with something else. One second here. We're coming in the greenhouse. Temperature is 60 degrees. It's like 30 degrees out there. 30 degree jump. So I found 24 volt DC heat tape. So I ordered that. And then I found a 24 volt DC thermostat. So I'm going to just wire the thermostat up. It's it's not mechanical, it is electronic. But anyway, it will draw the power off of the line to work. So I'm going to hook up that 24 volt DC drip tape or heat tape to the thermostat, and at 32 degrees I'll have it come on. 32 degrees outside, and then that heat tape will come on and stay on until it is not 32 degrees, until it's 33 degrees outside, and that'll be plenty warm enough inside the little box. So I've ordered that, and that's coming. I'm not going to do the light bulbs. I'm going to go right to the heat tape because it's worked so well. All that to say, I've found an off-grid way to keep my pressure pump safe. Here's my Egyptian walking onions. They're coming right along. They're happy in here. Now I'm going to take, it's going to be cold again tonight, but I'm going to go ahead and take these blankets off. So I'll be right back with you. So here's the whole thing. Ground temperature, 55, 60, 65 degrees. That's what it was last night. The ground temperature has not changed on these tomatoes. And it was probably 20 degrees last night. And what's important about this is that this, no additional heat. There's nothing plugged in, DC or AC. This is all just ambient air temperature, ambient soil temperature, ambient water temperature, working in conjunction with the 2 layers. I got the polyacrylic on the outside, and I just got regular greenhouse sheet metal plastic in here, and then this back wall is insulated. Unaided, unheated greenhouse, just what it is. Now I do kind of have a walipini thing going on here, because I am, where I'm standing is maybe 2 feet below grade. Probably not quite that, but approximately 2 feet below grade, but we're below the frost line. So this will never frost, theoretically, and it hasn't yet. And even that is probably below the frost line, usually. We're using ambient ground temperature. We're using good insulation. I've patched up all the cracks. This is not a great greenhouse, but it is sufficient for the purpose. It is doing the job. There's a lot of things I would do better. I built this thing on the cheap, and I made some mistakes, but I have learned a few things in the doing of this, and it is still keeping tomatoes alive. And we have had enough cold days in a row that we're like maxing out. We get five or six really cold nights in a row here. We usually don't get more than that. And if we have not got the ground temperature down below 65, it looks like I'm going to pull this thing off without additional heat. Now, if we get a cold snap that lasts for a couple weeks and we have a lot of clouds and we're not getting the ambient temperature built up in here, I could probably have to take some measures. So we are kind of chancing it. Nothing's a done deal. But the tomatoes are alive. We got through the shortest days of the year. Now we're getting longer days every day. We're almost to mid-January here. So the days are getting longer and longer. We're getting close to 3 to 4 weeks past solstice. That being said, we're going to have longer and longer days and more sunlight. I don't care about these things fruiting. I don't want them to fruit. I would pluck anything off anyway. It wouldn't get pollinated. I just want them to stay alive so I can have a really great start just past frost to get some tomatoes in the garden and get super early start. And when you have these suckers, they go to fruit way quicker than if you go from a seedling, because it's an older plant. It's further along in the process. So anyway, this is working well. Everything's still green. There's a blossom. It's trying to blossom. We'll let it try. I said I'd pluck it off, but that's right there near the ground. It's kind of its own little plant. Got its own roots by now, probably. So I'll just let it do it. If it thinks it wants to, we should just let it. Because just think when it's... Yeah, and I'll get some of this dead stuff out of here. I don't want any mold issues. So everything's looking good on these tomatoes. I might just pull it off. We are using those blankets to hold the heat. I'm pretty sure it would be dead because this was my kind of my control subject here. Yeah, that's dead. That's dead. This looks like it's still green. Doesn't know it's dead. I don't know. Maybe it's... Well, let's see how it goes. Anyway, I'm going to show you one other thing. Anyway, unheated greenhouse. Tomatoes still alive. Zone 7. It's definitely cold today. Not a lot of wind though. Still in the shade, and it says it's 30, 34, 35. I'd say that's right. Hadn't had the sun hit it yet. So I'm going to show you what I did spend some time on the mill yesterday. Didn't really tape it. So we got these posts in. This is my header. This is a bad cut on a piece of white oak. White oak is actually very durable to the weather, especially when it's kept up off the ground. So that's my header. I'm going to get that up there, bolt it in. You see that hole above the door, that little notch right there by that big screw. That is where my rail goes, and it's going to come out here to this, and this beam is going to hold it up, hold up the rail. But the beam is also going to hold up a chain fall. I'm gonna go to Harbor Freight and get one. It's pretty well rated, 1 ton one for like 65 bucks. And the rail is gonna be offset of center, but there should be enough room for a carcass. No problem, it's not gonna bump into this post here. And then the chain hoist will be off center to the right. I'm just doing that. Yeah, I have the loader. The loader's not working right. I think it has injector issues. After the head rebuild, I think I dinged up the injector, so I'm not sure. But hopefully, I did get an injector tool. I don't know what I'm doing with it, but I'm going to try to test my injectors and see what's bad and good. And if I have a bad injector, I'll either rebuild or buy another one, whatever, or a couple, whatever it takes. So I will keep you involved with that because I'm learning. I'm a novice shade tree mechanic on that. So anyway, here's the little bit of progress we did make after chiseling through the frozen ground and getting that post in. And that was a branch, and it was crooked, it wasn't, so I sawed it and tried to get it as straight as possible. This bottom is probably gonna outlast that top anyway. There's a lot more red to it. It is a cedar post, so. And I'll notch once I figure out the height I need, and I'll probably build a little platform to stand on so I don't break my neck trying to get that. And what I was saying is the loader's questionable right now, so I want to get it to the point where I don't have to have a loader over here to work with even a full cow. It'd be more like, let's say I have to shoot the cow out there, or whatever I got to do. Maybe I don't bring it over here to slaughter it. Maybe I kill it on a different part of the land, and I drag it over here in the back of the truck, and then I'll just hoist it up off the back of the truck. I don't need any equipment here. I'm all set up. I decided to go like that. I was going to rely on the loader. I decided to not rely on the loader. And if I'm loaning this blocker to somebody, let them bring their cow over or whatever, then they can just come over here and use the chain fall and get it in there. They don't have to worry about my equipment or anything like that. So I'm just trying to do it in a way that's most likely to have the most options. So that's why I'm gonna go ahead and put the chain hoist in. So anyway, I'll update you on that as we get it bolted together. I'm not doing it today, it's just too cold. I'm gonna walk you over and show you what the main project here, the actual getting something done and not just standing around talking. So that's not too bad in here, better than outside. So that charge controller is shot. The load side doesn't work on it, and I'm not even sure it's charging the batteries right. Where am I? There it is. In the pocket. So this is an MPPT, Maximum Power Point Tracking Solar charge controller, which is better than the PWM, which is power wave modulation. That's the cheaper ones. This one can handle different loads, different charges. It makes everything work. It's smart enough to figure it out, where those cheaper ones, not so well. So I'm just swapping this thing out, and that will be charging the battery. I'm not even going to really use the load on this, probably. I want to get an inverter going, but I'm probably going to take an inverter right off of this breaker. As long as it's a 24 volt inverter, I don't have to worry about using the load on that. I'm going to go ahead and swap out these wires and get that going. It's reading 14.4 on a 24 volt power bank. It's just, who knows what it's doing. It's supposed to be 24 volts. I will get this wired up and let you know. You can see the difference in the sizes here. Yeah, I thought they were almost the same thing when I ordered it. And I got a deal on this, man. It's a true maximum, it's the MPPT. And this one was 60 amp. Biggest one, I got it for like 15 bucks with shipping off of eBay. It's like the cheaper, the 30 amp is way more expensive than the 60 amp. And it is a true MPP. According to the reviews that I read, it's the real deal. So it's an absolute bargain. We'll see if it works. But right now, it would be good to be charging the batteries the way they're supposed to be. Because I got 24 volts coming in from the panels, and I got 24 volts worth of batteries, and this thing is saying 14.4 or whatever. So it's charging them, it's just not charging them the way it's supposed to. And it's important to note that you unhook the panels first, you do the batteries last. You start with the negative from the battery, then you do the positive to the battery, then you go to the negative to the the solar, positive to the solar, and then you go to the load, same way. And then you just, when you're hooking it up, you do it one way and you just go backwards the other way. So I'll take the negative on the battery off last. Then I'm going to swap this baby out and we'll see what we're doing. Well, I tell you, when you're working with these little cheap lugs, it is not that easy to get that 8 wire to cooperate. When you're doing it, just take your time. Look at what you're doing as you're spinning the screw. Don't just assume it's going in the right direction. Or put your screwdriver on it, spin it, make sure that the lug is moving up and down like you're supposed to. And open it up all the way, push your wire in there and start tightening it, and don't over tighten it. Just kind of tighten it and tighten it. You kind of got to be careful and not over tighten things and ruin those lugs, because then you'll have junk controllers like I do. That's basically how I run them. And when you get them mounted, don't move them around because those wires, those lugs are not that strong. My panels, I'm not sure of the reading here. I don't know how to work the thing, so I'm not sure of any of this. So I have to read the directions. 28.4. I guess that's the batteries, because it seems like the panels should be bringing in more than that. They should be over 30 probably. But 28.4 is probably my battery bank, so everything's probably charged. I don't know if that one was working or what. But at this point, we're where we need to be. So what I would do next is no load coming out of the controller. I'm going to go right into the load center. There is some. Let me take this cover off and show you something. So a very important tip bears repeating. Homelite QO load center. Do not do the Homeline. QO load center works for solar, works for DC. It is rated for it. You don't have to buy that expensive stuff from those solar places. You can go to the box store, hardware store, and get this QO load center for what, 50 bucks or whatever. You got to buy your breakers separately, but you're going to save a ton of money on this. Don't try to get all the fancy upgraded solar things. Just get the Homelite QO. Everywhere. It's everywhere. It's available. And it's the most affordable way. So coming in off of my batteries, this is my negative. Let's see what. This is actually my load out. My load in is here. Sorry. So this is to the regular ground strap, neutral strap, whatever you want to call it, common, whatever you want to call it in AC. But in DC, this is just going to be your negative, your black, your minus. And here's my plus coming in. Am I showing the wrong thing? Okay, this is it. I'm sorry. This is my positive coming in. This is my negative here to that. Now, you have a positive lug here and a positive lug there. That's the negative. That's the positive. That's the positive. Because on 110, you have two hot legs coming in. So what you have to do if you're going to use all of your breakers is you have to jump. If you're coming in on that lug, fine. That means every other one of these breakers will work. Coming in on this lug, these ones will work. Every other one, because it's back and forth. You have to jump it over, but only in DC. Don't do it in AC. But in DC, you can jump your leg over and then you're going to energize both sides of this thing, and then you can plug your breakers in and all of them will work. But for right now, I just need one more, so I'll just move this breaker, skip one, put it over there. Now you got to knock out the hole on this thing, and you got to knock them out right if you're going to be skipping. Don't knock them all out. Knock every other one out. And that way you don't have holes. Or you just get another breaker to fill the space and don't use the breaker or whatever. But you're not going to get all your breakers to work and be like, what's going on? You have to figure out which bar you're on and use that one. And one confusing thing on this thing is you got to buy that part separate. Like in a lot of boxes here, it's already going to be there. In this one, you got to buy it separate. And that's my ground. I have whatever that is. That looks like a number 6 solid. And that's goes over to a ground strap. So I have my system grounded there. All this to say is I'm going to get a breaker here and I'm going to run my inverter from here. I got to make sure it's a 24 volt inverter. Make sure it's not a 12 or 36 or anything. It's got to be 24 because that's my battery is 24. So I got to have a 24 volt inverter. But I don't really need that much power here. But I'm going to go ahead and have it where I can just plug things in. Like kind of what I'm doing here. That's tied into my regular AC on-grid electric. So I'm going to try to do a similar thing. It's going to be off-grid. I'm just going to have my inverter right here and wired right in, directly in, no charge controller or anything like that. It's going to go, and this is essentially the same as wiring it into my battery bank. Now I can't put a big inverter because my wires coming in, this is only number 8, good for 40 amps or whatever. We can't run a high amp load. We can't run big stuff or we're going to overheat our wires. So it has to be a smaller inverter and it has to be 24 volt. But that's what I'm trying to achieve here. I'm not going to run any big loads on it. I just want to have the option if I have to plug in a radio or I want some lights or run a power tool or a battery charger or whatever, I'll have that option. And I'm not using my charge controller at all for that. Now if I needed something 12 volt or 36 volt or something, you can put a different size load because of this MPPT. Not on a PMW or PWM or whatever, not on those cheaper ones. You have to match those. MPPT do not have to have matching voltage. They will figure it out and they will optimize what's going on as best they can. But if you're 36, you're probably going to have some trouble. If you had 36 going down to 24, it'd probably be easier. Trying to expect this. But this could take it up to 30. If you have 36, if you're whatever your load is and it'll run at 30 volts, this can get it up there because your panels are coming in at 30 volts. It can optimize what it has to work with, but it's not going to get up to 36. But it can go all the way down. So if I have 24 volt battery and I need to get down to 12, this can easily step it down. It's stepping it up, I think, is a little harder because it doesn't have enough to work with. And even if it's stepping this down, it's only going to be able to take it down to the battery. So 14.4, or whatever the batteries are, if you're running 12 volt, it's going to get everything as close as it can. I just know MPPTs are more expensive and they are better if you're different volts. If you have the same volts, you can use the cheap things. Just don't ruin the lugs on them. You got to be careful of those stupid lugs. You'll see they're a pain. You buy the better equipment, they got better lugs. But they're also a lot more expensive, and a cheap one and an expensive one can fry out just the same, especially from lightning strikes or whatever. I'm just using the smaller. I'm not trying to do a whole inversion from DC to AC and run my house as normal. I'm trying to run DC as much as possible, so I'm skipping as much inversion as possible. But that being said, I still want to have the AC option. So that's why I'm going to use smaller inverters. I'm not going to use big inverters. If I burn up in a cheap inverter, I'll just have another one back up and use that. Now, I could be wrong about this approach, but I'm trying to keep it a minimal expense and maximum flexibility and keep it on a smaller scale. Just trying to do your whole grid tie, it's just so expensive and it's just so unnecessary if you approach it differently, in my opinion. So I'm glad to have that discussion with anybody that wants to. I think my way is more sustainable and more approachable for most people. Not everybody wants to go $75,000 or $100,000 in debt for solar on their house. And I think staying away from debt. And if you start with small systems, you can at least get familiar with the way solar works and figure out how to adapt to your needs as they change. The problem with having those huge systems is you got to adapt backwards. I would rather adopt up than adapt going downwards. And a lot of those systems, they just don't really have the batteries. It's all about trading credits. It's all about selling them power cheap and then they'll give you credits. It's all about just not having an electric bill. I say that it should be more about how do you live not grid tied and how do you get done what you need to get done. Forget about the electric bill. You don't want it. A lot of those guys with the big giant solar systems grid tie, a couple weeks out, they're going to be in trouble because they can't do what they need to do. Maybe they can, maybe they can't. The smaller guys with smaller systems are going to be doing exactly what they need from the start. Anyway, think about it and talk to me about it if you like. So anyway, for now, I'm going to just go ahead and sign off. I'm going to go in and warm up. And y'all have a good day. Wiggle out.